Okay, again, I always say that I'll post a video of me doing the computation, but right now I'm not really interested in the computation. I'm interested in how to set this thing up. And the first thing I notice is they give me a function, and they're saying use Newton's method to approximate unique real root of this, and they say f of x equals 0. So I kind of see the problem as being sort of simple. I mean, I got the function, and they want to know when it's equal to 0. And that's this root over here. All right. So, you know, if you have the computer, you can blow this thing up and look at the number, and you can make a really good guess about what the number is. All right. So I'm going to just scroll back down, and I want to set the problem up for you. The first thing to do is write what f of x is. We're looking for the 0. It's a cubic polynomial. And then I'm going to write the derivative down. Relatively simple to do. That's going to be 3x squared plus 2. Let's see if I did that right. Yeah, 3x squared plus 2. And then what I do is I got to get an initial guess. And I'm going to look at it, and I realize for some to say, I don't know how you came up with that guess. I looked at the picture, all right? So the guess I got, the initial guess, looking at that picture, I'm going to say my initial guess. I'm looking at the picture, by the way. Maybe I shouldn't say it's equal. But, you know, I say my initial guess. This is what my initial guess is. Minus 1.17. Now, let's say you said, I didn't get that one. I wrote a different one down. All right, let me go through that with you. You'd have to write down what you're guessing at, by the way. So if I look at this over here and I say, oh, my initial guess, I want to make it something different. And I kind of zoom into this over here. And, you know, this is, you know, minus 1. And I'm looking at it's minus 1.25. So let me just take a look at that. I'm going to say, you know, kind of looking at it, I'm going to say this would be minus 1.1, and this would be minus 1.2. You get the idea? And then if I looked at this in between here, I might say, oh, minus 1.15, right? Now, someone says, what would this be over here? Well, it's somewhere in between. I hope you realize that just looking at it. And that's why I came up with the minus 1.17, just by looking at it, all right? So I'm going to say that's relatively simple to do. But again, you may say, I didn't get that, I got something different, I got minus 1.2. It's not going to change your problem, by the way. It's going to change your computations, but not your problem. All right, let me go back over here, erase this over here, and let me just go back and say, let's stick with the number that's given us. So when I do the computation, I can match the numbers, all right? And again, I'll go through the computation on a computer for you. But I'm going to say my first guess is going to be minus 1.17. Then someone says, how do you get x1? x1 will be equal to or assign the value x naught minus f of x naught over f prime of x naught. So again, I'll post a video, and I'll put the link in the notes, by the way, where you see me computing these numbers over here. Now, someone says, you know, why'd you stop there? Well, you know, I'm going to say, reading it over, I'm just going to use Newton's approximate, and I'm going to tell you, there's a reason to stop over here. And I'll tell you the reason why is, you know, maybe it just didn't change after that. Maybe the next one I computed was the same exact number, all right? Now, when I post a video, I'll go through that. But right now, all we're doing is setting it up, coming up with an initial guess, and writing down the algorithm for generating more and more guesses as we go through that. But again, I will post a video of that. Thank you.